Let's convert a string to an int in Java. Here we are in IntelliJ IDEA. We'll create a string called input and assign it a value of 2319. And we'll create a variable called output of type int. We'll invoke the static method parseInt from the integer class and pass in the input variable. And we'll write out a string using the printf method and use the %d format specifier to print out the integer value. Let's run that code. And we get the result, the string converted to the integer value of 2319. So that's it. That's how you convert a string to an int in Java. Use the parseInt method from the integer class. But if you want to know the real story on parseInt, how to handle errors correctly, and why the value of method might be worth considering instead, keep watching. Let's change our input string and add a random alphabetic character, in this case the letter U, and run the code. We get a big, ugly stack trace. We get a number format exception, which is thrown by the parseInt method when the string cannot be converted to an int. Number format exception is an unchecked or runtime exception, meaning it can be thrown during the normal operations of our application. If we don't handle the exception somehow, by catching the exception and dealing with the problem, it will kill our running application. Let's see what happens when we have a null value in our input string. We'll set input equal to null and run the code. We get the same thing. Once again, a number format exception is thrown. Clearly, we need to handle the runtime exception. We'll initialize our output variable to 0 outside the try-catch block scope. Let's add a try-catch block around the part of the code that can fail. Inside the try-catch block, we'll set output equal to the result of the parseInt operation. And in the catch block, what should we do? We need to indicate that the parseInt call has failed. We could log the exception, which would be necessary in a production application. We also might want to set the value of output to be something special to indicate failure. For example, we could set the value to -1. Our assumption here is that the value of -1 indicates a problem condition that we would deal with downstream in our application. That may or may not be the case and really depends on your application and the range of valid values for the data you're processing. Let's run the code with the input value still set to null. Our output result is -1, so we handled the error condition somewhat gracefully since we didn't get an exception. Now let's set our input string back to the value of 2319 and run the code again. Our output is the value 2319, which is what we expect, so the happy path condition is working. Now let's set our input string to be the value of maxint. Values between just under -2 billion to just over +2 billion can be represented by the int type. We can convert the int represented by max value to a string by concatenating an empty string to the value of integer.maxValue. And let's run that code. We get the result of maxint value printed, which is 2,147,483,647. So what happens if we add 1 to the value of maxint? Let's do it and find out. We'll surround the expression with parentheses for clarity and to avoid issues with operator associativity. And let's run that code. Notice we don't get a -1 indicating an error, and we don't get the value of maxint plus 1. Instead, we get the result of -2,147,483,648. This is an example of integer overflow due to a behavior called integer wraparound. What it means is that we've exceeded the range of values that the int primitive supports, so our result has become negative. When doing the conversion, Java doesn't throw an exception. Instead, it silently gives us back bad data that we have to detect ourselves. So how could we fix this? We could use a different type to hold our result, such as a long primitive instead of an int, but longs can overflow as well. A better solution would be to use the big integer class, which is limited only by the amount of available memory. 2 more things before we wrap up. Let's look at how we can specify the radix value of parseInt if we're working with data that's something other than base 10. Let's set our input string to 101, and we'll add 2 as the second argument in our call to parseInt. This indicates that our string 101 is binary or base 2 and not base 10. And let's run that code. We get back the result of 5, which is the value of 101 base 2 converted to base 10. Some online resources mention the method value of in the integer class as an alternative to using parseInt for the string to integer conversion. Let's try that. We'll comment out our parsint call and add in a call to value of and pass in an argument of 101 with the default to base 10. Running the code, we get back the result of 101. So value of looks like an alternative that we should consider, right? Let's take a closer look. If we drill into the method, IntelliJ will pull up the source code for the value of method. Notice in the code for the method, the value of method simply calls the parsint method, then calls an overloaded version of the value of method with that value, and returns an integer wrapper type. And then the value is assigned to the int primitive through a process called unboxing through assignment. The bottom line is the value of method invokes the parsint method and then adds overhead due to the additional method calls and unboxing. The value of method is slightly less efficient, and the parsint method should be the preferred method for converting strings to integer values. Thanks for watching, and remember to always begin secure.